Hello, everyone, and welcome back. Last week, we finished up the chapter on consciousness, focusing specifically on sleep as well as drug use and abuse, the criteria by which we determine whether someone becomes physically dependent on a drug, and then the different categories of drug and the effects they have on the nervous system. So remember again that we are talking about drugs in a chapter on consciousness because drugs are a method of achieving an altered state of consciousness. Remember that consciousness is your personal experience of all the mental activity that is occurring within your brain at a given moment. So, if you are introducing a chemical that changes something about mental activity, you are thereby going to change consciousness, your experience of that mental activity. To finish up a point that I've been making the past couple of times that I've introduced a chapter, I want to make this point again that your brain interprets information that need not match reality as long as it enhances survival. And I think that this concept applies well to the idea of drug use and helps to explain why someone may start to become dependent on a drug when from the outside, it doesn't seem like there should be a reason for them to do so. I want to ask this question and have you think, well, how might altering your consciousness in the way that drugs do, in the way that stimulants, depressants, or hallucinogens do, how might that enhance survival or may have improved people's lives and therefore made drug use an attractive option? Well, remember that stimulants are going to overclock the sympathetic nervous system. You're going to activate it more than it otherwise would. And so what you're doing is you're inducing the body to use more of its stored resources than it otherwise might. How might this have helped people who have used stimulants like caffeine or even more extreme versions like methamphetamine or cocaine? Well, remember that stimulants were for a long time considered a useful weight loss supplement. So although stimulants altered a person's consciousness, tended to make them jitterier, tended to hype them up in a way that might have caused distress, it may have benefited them in their endeavor to lose weight. Now, did it harm them in other ways? Absolutely, potentially. However, that was a byproduct. So it's possible that you would be willing to manipulate your perception of how things are happening around you if there is another alternative benefit to it. Likewise, just using caffeine in general, people tend to be willing to alter their awareness, how tuned in they tend to be, how focused they feel, how active their sympathetic nervous system is, if there are things that they need to get done, if they feel that they need that extra amount of focus and stimulation. So it may have altered perception of reality. They may have felt more awake or that they had more resources to use from their body than they otherwise realized, but doing so helps a person potentially get past these demanding challenges, these demanding times in which you need that extra boost. Likewise with depressants, again, using our favorite example of alcohol. Alcohol is something that is going to alter how you perceive the world. Depressants tend to slow down the activity of the nervous system, specifically inhibiting certain types of neurons from activating. And although alcohol is a general depressant, it can also specifically targets the prefrontal cortex, that frontal lobe that is helping you to make decisions, that is involved in executive planning. Well, remember, even though it could be intoxicating, it could alter your perception, drinking alcohol historically may have been such a widespread human activity because there were some times in which you wanted to inhibit that planning, that thinking about how your actions are going to affect the future, disinhibit your impulses, such as if you're at a party and you want to flirt with someone and you want to make that connection. It's possible that the benefits of inhibiting your inhibiting your decision making, your prefrontal cortex, outweighed the cost of potential physical dependency. And so one could calculate that is a survival advantage that this drug can provide that without it, at least you feel, you otherwise could not achieve that at a social gathering. Likewise with hallucinogens, I think hallucinogens are very popular now, in part because, again, THC is more widely available than it's been before. Those of you who have not heard, uses of LSD and psilocybin, other hallucinogens that have been used for medical purposes for treating depression and anxiety disorders. What we're finding is that you can alter people's perception of sensation, of, say, the vividness of colors or the vividness of sound, or how intense certain sensations feel, and that seems to have some medicinal benefits in certain situations. So altering perception may be useful to us in certain, for example, medical situations. So I think that adopting this perspective, that there may be advantages that drug use has provided certain people, is important to keep in mind. It might frame why someone would begin using a drug in the first place. But remember that there is that risk of physical or psychological dependency. So although it seems that there's a benefit to using particular drugs, there is also that potential, the downfall of becoming tolerant to a drug, experiencing withdrawal symptoms, and becoming needing that particular drug to continue a feeling of well-being, or your body being able to function. So there are trade-offs to everything. Again, drugs are one of those things that you personally are going to have to make a decision about whether you use or do not use. I've already mentioned some that I think personally you should stay away from. I think that it's a fairly steep slippery slope. But again, I think understanding how drugs affect the nervous system and keeping in mind what effect they are having can help to frame your experience, and therefore how appropriate it is for you. So keep this in mind. I also encourage anyone who, if we've gone through this section and there are certain classes of drugs that I have not talked about, or questions that you have, or even up to personal issues or advice that you'd seek, again, this is one of those classes where you can talk more freely about drugs. My focus is on understanding it and using that to your well-being. So if you have these questions, please do. You can reach out to me. You can ask me questions, and I'd be happy to help you. That's my disclaimer. That's my cap on the consciousness chapter. So now we're moving on to human development, chapter on human development. And here's the way to think about human development. Everything that we've been talking about in terms of learning and memory and the biology of the nervous system and how it develops and how your body takes in sensation and thereby produces perception based on that information and produces an experience of consciousness. Human development is going to be, how do each of those capacities change across an individual's lifespan? So how does thought, how does behavior change across time? We can take what we've been talking about, the physical and biological changes that occur within the nervous system, and think, how are they different? Is your nervous system, is the way that you perceive the world, is the way that you learn, or the memories that you stored, are those the same now as they were 10 years ago, 15 years ago, 20 years ago, depending on how old you are? Have they changed in some way? So we can talk about the biology of the nervous system. Is the biology of your nervous system acting in the same way now that it was before? For some people, for many processes in the body, how exactly enzymes or proteins are metabolized, how they contribute to the inner workings of neurons, what neurotransmitters are released and in what quantities, these things can change across time. And because altering those physical elements can alter your mental activity, how your mental activity generally occurs is going to shift with it. Sensation and perception, how you take in information, how you process it could change across time. Learning as well. The things that you are capable of learning now are different from those that you had the greatest ease learning when you were younger. A good example of this is language acquisition. If you are taking a foreign language now, a language that you did not grow up speaking or listening to, if you're taking a class on that right now, if you're in college, chances are you might be having some trouble with it, or it might seem like it takes a lot of time, a lot of investment. Compare that to when you were 2, 3, 4 years old, learning a language for the first time. It seems like children have a much easier time learning language. There's a reason for that. We actually have a language acquisition device built into our brains, a region of the brain that is activated when we are younger, around that age. And so very quickly a child can simply listen and be around people and pick up on different words and their meaning, learning how to string words together to form sentences, knowing how to express a personal inner thought to the people around them. That's an ability, the ability to learn that is active very early on in life. And then as a person progresses into about adolescence or so, that device turns off. You have a much harder time learning. So your ability to learn language has shifted across time. Likewise, how you build memories shifts as well. So if learning changes, well, the product of learning is going to change as well. It's going to be harder for you to store memories related to language as you get older. But also you have a greater raw number of memories in older age compared to when you were younger. How does having all the experiences, all the memories, all the life circumstances that have shaped your thinking, how has that influenced your development across time? We can think about memory in that way as well. And so again, if we are shifting each of these different processes in some way, we are thus altering consciousness, your experience of all of that mental activity. And that's going to change across time. All right, so how do we study this? If we're gonna, I need to introduce two concepts before I let you loose on the material for this week. First, we need to figure out how psychological scientists and other behavioral scientists study development, study change across time. And then I also want to get into a particular debate that exists within within developmental research called nature versus nurture. We'll get to research methodologies first. How would you study human development? If you had to study how a trait shifts across a person's lifespan, what would you do? Well, you might say, well, of course, what I would do is I would recruit a group of people, measure their capacity, their ability to do something now, and then follow up with them after some time has passed, maybe after several months, maybe after several years, and then assess that capacity again. So maybe assess how well someone can learn a language when they're 2 years old versus compare, and then follow them across time and see their ability to acquire a language 10 years later. This would be called a longitudinal design. That is, you recruit one group of people who is studied across time. An alternative to that is what's called a cross-sectional design. So in this design, your interest is still in comparing people of different age groups. But rather than follow the same people across time, you instead recruit different age groups at the same time. So you might recruit 2-year-olds and 6-year-olds and 10-year-olds all at once, rather than recruit someone who, when they're 2 years old, follow them till they're 6, and then follow them till they're 10 and reassess them. So what are the advantages and disadvantages of each of these? Well, The big advantage of the longitudinal design is that you are going to observe change, actual change across time. Compare that to a cross-sectional design. In a cross-sectional design, what you're doing is you are comparing people, different people, at different ages. And so the differences between people in a cross-sectional design could be due to the fact that there are developmental differences that exist between 2-year-olds, 6-year-olds, and 10-year-olds. Or it could be due to the differences between those people. Their individual differences. Maybe you've recruited a totally different group of people in each of the age categories. The people who are 2-year-olds are, due to their genes, due to their experiences, different from the 6-year-olds. With a longitudinal design, you control for that. So because you are studying the same people at 2, 6, and 10, you are accounting for differences that exist between people. You know that the only thing that differs between the 2, 6, and 10-year-olds is the amount of time that has gone by. That's the big advantage of a longitudinal design. Of course, the big disadvantage of following the same people across time is that it's very expensive. If you do a longitudinal study and you want to get participants to show up 2 years later, 3 years later, you're going to have to pay them. You're going to have to give them money. Otherwise, people don't come back. And even if they do, if they are well compensated, there's always the risk of what's called participant attrition. Attrition means dropping out. I'm on the university's retention committee. We talk about attrition all the time. What predicts whether a student is going to drop out of a class or drop out of school? This is a problem you have to deal with in a longitudinal design, because even if they're well compensated, it's possible that if you're recruiting 2-year-olds at a particular time, 4 years later, their family may not still be living in the same area. Things happen, times change, people lose interest, priorities shift, and so they're not willing to come back later. That's participant attrition, and that's the big risk of a longitudinal design. So it's expensive, and it's difficult to manage participants. Well then, okay, does the cross-sectional design address this? Yeah, it kind of does. It's easier data collection. Rather than having to follow people across time, you just need to bring people of different age groups together at the same time. So you collect data all at once, and then you're done. You don't have to ask them to come back. Of course, then, though, the big disadvantage is you're not accounting for differences between people. So what the differences you observe between the age groups that you've recruited could be due to their age, or it could be due to their personality, other differences between them. The other problem that you have for cross-sectional studies especially, but really this is a disadvantage in its own unique way for longitudinal and cross-sectional designs, are what are called cohort effects. Cohort effects refer to any similarities or differences between two age groups due to shared or different historical events. So that is, groups may either be more similar or more different from one another because of the unique historical events that they experience throughout their life. For example, let's say that you are interested in dating behavior, the kinds of things that people do to find a romantic partner, start a relationship, keep a relationship going, the way people break up with one another. And you wanted to look at that in 20-year-olds. So you wanted to make a generalization about how 20-year-olds tend to date and mate with one another. Now, to do that, what you could do is you could try to do something like a cross-sectional design where you are gathering people who are 20-year-olds now versus comparing them to people who were 20-year-olds several years ago, a decade ago, or 20 years ago. Although both those groups may be 20 years of age, The circumstances in which they were 20 and on the mating market and out finding a romantic partner might be substantially different. Nowadays, online dating apps, social media has really changed the nature of how people find potential partners. Back in the day, maybe all that you could do was you went to a particular you had community groups. You were most likely to find people in the area where you lived, in your workplace, or when you went to school, or if you went out to some kind of social activity or community event, or go to church. That's where you might find people. Now people's options are much greater. How people are dating and mating when they're 20 now versus when people were 20 years ago might be very different because of the historical circumstances. In this case, the availability of technology. So how do we address this? Well, there's a third design that combines the strength of each of these designs. That's called a cross-sequential design. So the last one was called a cross-sectional. This is cross-sequential. Like I said, it involves both longitudinal and cross-sectional designs. You study different age groups across time. So this graph right here does a good job of showing what kinds of data you can get from a cross-sequential design. Along the bottom here, we have what's called the year of testing. So this is when we've actually brought people in and tested whatever trait we were interested in, maybe their language development, again, their acquisition of language. So we brought them in when they were in 2002, when they were of a certain age. We brought them in during 2004 and during 2006. Then, because we're gathering people of different age groups and studying them across time, we can also talk about, on the y-axis here, people who were born, say, in 1994 versus those who were born in 1996. So at the year 2002, we're going to have a group of 8-year-olds and a group of 6-year-olds because they were born 2 years apart. Right here in 2002, if we're recruiting these two groups, we have a cross-sectional design. So we can make cross-sectional comparisons, say, in language acquisition ability between these two groups. Then when we follow them across time, we get the longitudinal data. So we can see difference in language acquisition when people are 8 versus when those same people are 10 years old. So these blue arrows represent the longitudinal information. So we have what we would normally get. The strength of a cross-sectional is that uniquely we can account for these green lines here, which are the cohort comparisons. If we're recruiting these children, say, when they are, these when they're 6-year-old and these when they're 8-year-old, that means by 2004, we actually now have 2 8-year-old groups who were born at different times. So if there was something that happened, a historical event, some circumstance that affected language development, let's say that there was a chemical spill in 1995, or the water supply was tainted, that there was a higher level of lead. These kinds of things happen. They actually happened to a town that I lived very nearby when I was in Michigan, called Flint. If something happened, a historical event occurred, and say 1995, and we're looking at when children were born, it's possible that these 8-year-old groups may differ because of that historical event, because of their exposure to lead. That has nothing to do with their other personality traits or characteristics or longitudinal characteristics. So uniquely, by looking at these two groups of 8-year-olds, we are able to determine the contribution of that historical event, of the differences between 8-year-olds that were born in 1994 versus 8-year-olds who were born in 1996. This is a cross-sequential design, and this is why it's considered the gold standard of human developmental studies. If you see research where they've employed a cross-sequential design, you should be impressed. Chances are it was a very conscientiously well-funded study, Because the disadvantage of this, first off, there are a few disadvantages. There are many, many advantages. But the one big disadvantage is this is even more expensive. It's even more difficult to pull off. It takes even more money, and there's more risk of participant attrition. So if there's an institution that can pull this kind of study off, it's fantastic. But often you don't see these for those very reasons. All right, those are some research designs that I want you to be familiar with, that you will need to know. I also then mentioned that I'd like to talk about what's called the nature versus nurture debate. Those of you who have ever seen this in another class, you may have seen this in a biology class, you may have read about this in a philosophy class. This is the question, okay, if people are changing across time, there are really two primary sources, potential sources of that change. So one, people may change across time because of the contribution of their biology, and specifically the genes that they inherited from their parents. We've already, what we're going to do this coming week is I'm going to show you just how genes contribute to the development of various psychological traits that you can acquire, that you can develop across time. So we'll see how this works, but there's like individual contribution of genes, and then versus what is the contribution of one's environment, your family, your culture, the circumstances that you grew up in. How has that shaped your development? Well, what we know about this debate for as long as it's been going on is, well, that this debate is now dead to some degree. And the reason for that is we know that both genes and environment contribute to development. So it's not, it used to be the question was, is a trait entirely determined by a person's genes, or is it entirely determined by environment? We now know that both of these play a contribution. However, the new debate is how much is due to a person's genes or biology, and how much is due to nurture. So could we say that a particular personality trait, or something like sexual orientation, or impulsivity, or interest in particular types of jobs or hobbies, are those psychological traits, those behaviors, more so controlled by your biology versus your environment, even though both contribute? Well, to answer this question is tricky, because according to our standards that we've been going through, talking about psychology as a science, to really say whether one of these is causing a change in development, we would need to be able to isolate or control for one of these variables while changing the other. Right? So if we want to assess the independent contribution of genes, we would need to be able to hold culture or family constant while changing the effect of genes, to observe what effect that has in an experimental design. Well, let's think about how we would do that. If you wanted, say, so what options are available to us? Well, what we could do is we could, like I said, hold environment constant, but alter the genes. Now that tends to be unethical. To genetically engineer humans when they are very young, and you can do that kind of thing, is something that we've decided as a society that no one should have the right to do. We shouldn't be able to genetically engineer people, especially without their consent, in ways that could be purely for experimental rather than medicinal reasons. So we can't do that. So the alternative is, can we hold genes constant while manipulating a person's environment? That we actually can do. Think about it. Where in the world could you potentially have two individuals who have exactly the same genes but grow up in different environments? Well, twins, identical twins. That's what makes identical twins identical, is they share 100% of their genetic information. How that works, and we'll learn about this in this week's videos, is you have sperm and egg meet. They form what's called a zygote. It is a single-celled organism. Everyone used to be a single cell, like the combination of mom and dad's genes. Then that single cell is supposed to split, but not entirely split from one another. So you're creating two new cells, but they tend to stay connected. An identical twin occurs when, as that cell, that initial zygote, is splitting, it splits all the way, such that you get two totally different individuals, but they have the exact same DNA. So we can do this, and there are very large research institutions dedicated to studying the contribution of nature and nurture to our development by bringing in identical twins, being able to assume that genes are held constant, and then, for example, see whether their environments differ. That is, how do twins behave when they are reared apart versus when they are reared together in the same family environment, or when they come up in the same womb, or they have kind of different biological experiences before birth. So what I want to do is I want to show you a video that's related to this. This is a talk by a professor of psychology who is very prominent in the field of twin research. Her name is Nancy Siegel. She'll go into, I think, some of the more fascinating things that you'll observe if you start studying twins, and you'll see just how much of our development tends to be, I think, it's not always obvious how much of development is due to genes, and twins help to reveal that. So I'll show you this video now. Enjoy.
Let's talk about twins. Twins turn heads wherever they go. Seeing two identical infants, children, or adults is irresistible, causing us to peer into baby carriages, stare into playgrounds, and even ask rather personal questions such as who is older, who is smarter, and who decides what both of you will do, as if everything twins do is exactly the same. Society tells us that we all differ in appearance and behavior. So when we encounter two people who look and act so much alike, it challenges our belief in the way that the world works. But we find ourselves intrigued and drawn into twins' lives, trying to understand them. For most of human history, psychologists believe that we are largely products of our environment. But twin research is teaching us that so many more of our behaviors than we ever would have imagined are influenced by the genes. There are two kinds of twins, identical and fraternal, and both are essential in twin research. Identical twins result when a single fertilized egg divides within the first 14 days after conception, and these twins share all their genes in common. Fraternal twins share half their genes on average, just like ordinary brothers and sisters, and they result when a woman releases two eggs at the same time that are separately fertilized by two separate sperm. We can compare the similarity of identical twins in running speed or in how fast they solve math problems to the similarity of fraternal twins. And if identical twins are more alike, and they usually are, this tells us that the genes play an important role. Now, most studies use identical twins raised together, but studying the rare pairs of identical twins reared apart is even better, because if identical twins raised apart are as alike as identical twins raised together, this is even more compelling evidence that genes are important in our development. Think about the identical Jim twins, Jim Lewis and Jim Springer, who grew up in different Ohio cities. They didn't meet until they were nearly 40. And they discovered that both twins bit their fingernails down to the nub. They both drove light blue Chevrolets. They both had mixed headache syndromes beginning in their teenage years. And they both liked to vacation on the same 3-block strip of beach in Florida. The Jim twins also both named their sons James Allen. Now, James is a fairly common first name, but Allen is a much less common first or second name. Both of the twins had worked part-time in sheriff's offices and part-time at McDonald's. And they loved to scatter love letters around the house for their wives. And in a curious twist, both twins had married women named Linda, divorced them and married women named Betty. But then one of the Jim twins divorced Betty and married Sandy. We know that divorce is a partly genetically influenced trait, so you can imagine the worry on the part of the remaining Betty. Now, what about the twins Jack and Oscar? They had dramatically different environments, but even that did not prevent them from amassing a whole list of similarities that surpassed even those of the Jim twins. Jack was raised Jewish by his father in Trinidad, and Oscar was raised Catholic by his grandmother in Nazi Germany. And when they met for the first time, they discovered that both twins liked to wear rubber bands around their wrists. They thought it was funny to sneeze loudly in elevators. They both washed their hands before and after using the toilet. And they both read books from back to front. And they hated floral centerpieces because they said it blocked the view of the person seated across the table. How do we explain these similarities? Well, it could be that reading books from back to front suggests impatience, or sneezing loudly in an elevator is a cry for attention. But regardless, the fact that we see these similarities repeated in identical twins so much more than fraternal twins tells us that genes do play a role. Dorothy and Bridget reared apart twins in Great Britain. They show us that you don't have to live with somebody to be like them. You only have to share their genes. When they met for the first time as adults, both twins were wearing 7 rings, 3 bracelets, and a watch. And the similarities did not stop there. The twins described themselves as short-tempered, disciplined, and strict. They liked the same brand of perfume. They liked the same kinds of books. They had worn nearly identical dresses to their weddings and carried nearly identical floral bouquets. And they remind me of the identical reared-apart twins, Mark and Jerry. Mark and Jerry grew up in different cities in New Jersey, and they didn't meet until they were in their early 30s. They were both volunteer firefighters, but their signature quirk was holding a can of Budweiser beer with the pinky finger underneath. And you can see that they also carried huge key rings that they attached to their belts. Belts had huge buckles on them. They both threw their heads back sharply when they laughed. They were 6'4", bald, and heavily mustached. And when I took them out to dinner, I discovered they had a shared passion for Chinese food and for steak served extremely rare. And I also studied Barbara and Daphne, the Giggle twins. My colleagues and I affectionately call them that because when they met for the first time, they discovered that they laughed uncontrollably with each other and with nobody else. And they had the same crooked pinky fingers, the same disinterest in politics, and they drank their coffee cold, black, and without sugar. These twins had had a first miscarriage in their first pregnancy, followed by 2 healthy boys and a daughter. That may not be so surprising, because female physiology may in fact the sex of our children, and in this case, the physiology was perfectly matched. Shortly after they met, they concocted a drink called Twin Sin that was made of vodka, blue curacao, creme de cacao, and cream. My colleagues and I thought it was a little curious, but the twins thought it was just delicious. I finally want to mention two sets of identical twins, males, born in Colombia, South America. One pair from the city, one pair from the country. We don't know how this happened, but early on in the premature nursery, one newborn twin was accidentally exchanged with one newborn twin in the other pair. So these two sets of brothers grew up thinking they were fraternal twins, when in fact they were completely genetically unrelated. When they were 25, the truth was discovered, and the real pairs were reunited. I went down to Bogota to study them, and I discovered that the personalities of the reunited twins aligned almost perfectly. In one case, the twins were outgoing, gregarious, risk-taking, and in the other case, they were introverted, a little cautious, a little restrained. Again, we don't fully understand the reasons behind these similarities, but seeing them repeated in identical twins, more so than fraternal twins, gives us a genetic perspective on human development. Now, we need to think seriously about these findings because they have huge implications for how we raise our children and how we can all make the best of our abilities, our goals, and our dreams. In my experience, parents of one child are environmentalists, and parents of two children are geneticists. And I say that because parents of two children realize rather quickly that what works for one child doesn't work for the other. And that's because children come into the world with their own genetic predispositions that lead them towards certain activities and places and opportunities. Parents have to have realistic expectations about each child. Two dancing parents may not have a dancing child, because even though each parent shares half their genes with the child, genes get reshuffled in each generation. I tell parents, you don't really bring up your children, they bring you up, because each child evokes certain treatments and certain responses from each of their parents. A child with athletic abilities should be given opportunities to play sports. An artistic child should be given opportunities to paint and to draw. And a shy child should be given opportunities to speak up more, encouraged gently to do so. In this way, parents can make a huge difference in the lives of their children. And I also want to acknowledge the teachers and the mentors and the managers who work so closely with twins and others and affect their lives. As a psychology professor, I identified a very promising undergraduate student, one who showed real ability, talent, and drive. But he was the first in his family to go to college, and he lacked guidance and opportunity. I worked with this student on a number of projects, and today he is an advanced graduate student at the prestigious University of Michigan. Back to our twins. Twins are not just mere objects of fascination. Just by being themselves, just by acting naturally, they give science a powerful tool for understanding genetic and environmental influences on behavior. And in this way, they tell us about our humanity, why we are the way that we are, and how we got that way. Thank you.
Okay. So, hopefully you found that interesting. This week, we're going to be going into human development. We'll start with prenatal development, some of the changes that occur to the nervous system, to psychology before an individual is born, including we'll talk about DNA and its contribution to the development of psychological characteristics. And then we will move into postnatal development with a focus on Piaget's theory of child cognitive development. So that is what's to expect. Thank you again for listening, and I'll see you next time.